Hello everyone and welcome back to another video, and today I have something really cool to show you because this is the first new EPower design since I guess the EVGA EPower 5, which must have been sometime back in 2016. So yeah, this is kind of exciting because not only is this a new EPower design, it's also a somewhat open source design. I'm not really sure. This is a design made by Asyq, who's another overclocking YouTuber here in Germany, and he sent me these two samples of his B2 version of his new EPower. Now, first off, let's get the bit of a confusing part out of the way, because every single time I talk about EPowers, there's a lot of people who don't really know what these are and what they are for, because they are pretty crazy modifications. So, EPowers, also sometimes called external VRMs or zombie VRMs or zombie mods, are essentially the idea of you have a component, usually a graphics card, but it can also be a motherboard sometimes, where the stock VRM, the voltage regulator that turns the 12 volts from your power supply into the 1 point something volts that your CPU or your GPU or whatever you are powering needs. And that stock VRM can be too weak, or it can be broken, or it can have other issues that can't really be fixed. There are some graphics cards from the 600 and 700 NVIDIA series that have on-semiconductor voltage controllers that have an overvoltage protection that you can't really get rid of. So you can't overvolt them for overclocking, even if the rest of the VRM is fine. So in those cases where the VRM is broken, or it's not powerful enough, or there's any other issues that you can't really fix, but otherwise the card is fine and you want to overclock it, you use one of these. Because what an EPower does is it completely replaces the stock VRM of, let's say, a graphics card, and what it looks like when it's done is something like this. So, this right here is a GTX 980 that has a broken vCore VRM. I did repair it once and it worked for a bit, but it failed again, and after that I was just like, well, you know, let's just EPower it. And that's what I did. And I even EPowered the memory VRM as well, because this is one of my GTX 480 EPower boards, which I make these out of dead GTX 480s that I cut in half and then modify a bit so that the VRMs work without the rest of the GTX 480 attached. But yeah, this is the sort of DIY style of EPower. I have a few more examples I'm going to show you in a bit. And yeah, so you can see this right here is memory power, this big thing here is vCore power, and then these small strips down here are all ground. And that is how the EPower is attached. So voltage, like positive voltage, like vCore voltage goes in through this, memory voltage goes in through this, and return current goes back through these ground connections right here. And yeah, you can see below that there's a whole bunch of empty solder pads because the stock VRM is gone. There's nothing left because we've completely replaced the stock VRM with this EPower. And yeah, honestly, if you ask me, there is no other mod in extreme overclocking that is cooler than this, because it is just, you just completely disrespect the card and just tell it, you know, power limit, gone. Voltage limits, gone. Any control that the driver has over how you're running your card is gone. Like, the card is getting power and it's gonna turn on and it has no choice about that. So EPowers also are very useful for getting rid of all kinds of artificial limitations like power limits, because, well, there is no way for the card to interact with the EPower. It's just getting power from it, and that's it. It can't do anything about that. So yeah, this is what it looks like when they're done, and this is you know, what they're being used for. I hope that was a good enough explanation. That doesn't take ages. And yeah, so this right here is an attempt to make those EPowers a bit more proper, because what I just showed you, like I said, is made from a dead GTX 480. Here's another example that I put a little bit more effort into. So you can see the cut that I did right here. You can see where the memory modules once were. So I cut the GTX 480 in half, And then I do some modifications, like I attach a little buck converter to power the voltage controller. Here's the voltage control for the core voltage. I bridged some 12 volts together because part of this was powered off the PCI Express slot, which is no longer there, so all the 12 volt power needs to come from the two plugs here. And then there's a little resistor right here that connects the memory voltage output to the controller, because by default that gets disconnected when you cut the card. And yeah, that's really all you need to do to make this run. Once you're done with that, you just attach your connections here, which are very convenient on the 480 PCB. So yeah, and this is a fairly nice, very cheap to make DIY EPower that is very useful. I've made quite a lot of these. They are not super strong, but they are okay for like a GTX 980. Like anything that doesn't really draw more than 300 watts unless you really push it is gonna be fine with an EPower like this. But still, this is not, completely proper. It is still a bit sketchy. You need to modify quite a lot of things. I'm just noticing this is disconnected. I don't know where that is from. I hope that's not important. Where is that from? Yeah. Whatever. This video is not about this EPower board. So yeah. What was I talking about? Yeah, so you still have to do some sketchy things to this. Like you have to buy a dead card and then cut it in half and modify it a bit to get this EPower out of it. Another example is this right here. This used to be a GTX 980 Ti. This is a fairly nice 8-phase VRM, but there's one problem here, and that is the hookup points. Now this has a somewhat okay layout. I could remove these capacitors off the back and then have somewhat of a stripe of ground and VCore, or like solder wires in between these capacitors here, but this is leading into the main problem with EPowers that you make yourself from cutting old broken cards in half. You can't really connect them that well. I'm really lucky like that the 480 EPower has this big stripe of ground and VCore and memory right here. Like this is very convenient, and you rarely get something like this on PCBs. Even this is fairly rare. In most cases you get maybe a few capacitor pads that you can use, and that's it. And that is not really enough for an EPower connection. You are pushing a lot of current. Like when you're really pushing the card, hundreds of amps sometimes through these connections, and they need to be as good and as wide and as low resistance and as low inductance as possible. And if all you have is a few capacitor pads, that's not enough. You need more than that. And that is sort of where the idea of this EPower starts, or just the idea of purpose-made EPower starts, because this is not the first purpose-made EPower. I've mentioned the EVGA EPower 5, which was just a thing you could buy from EVGA for around 150 euros. It was a very powerful 12 plus 2-phase VRM with integrated tiny little interface for setting the voltage, a very fancy, very powerful, also very expensive. And then the Asus had one, which wasn't publicly available. Gigabyte had one, which also wasn't publicly available. Galax had one, which was somewhat publicly available. And then EVGA had like 2 older versions as well of the EPower board, which you also could get. So yeah, this is not the first time that someone makes a purpose-built EPower, but this is the first time that this was done by just someone. Not a corporation, not someone who makes this in secrecy or demands a lot of money for this. As far as I know, Asyq has mentioned that basically as long as you can prove you know what you're doing, you're just gonna get the plans for this, and then you go to any manufacturer, like today's sponsor, PCBWay, and upload the files there, tell them what you want. Maybe you don't like green, maybe you want one in red, and you can then order that PCB from them, and it arrives at your door. So essentially, you only have to pay your manufacturer. As far as I know, Asyq hasn't mentioned that he wants to be paid for the plans. So as far as I can tell, this is a somewhat open source design with the requirement of you have to somewhat prove that you're able to put this together. by yourself, because he doesn't want to just send this out anywhere and then someone who has no idea how to build an EPower gets their hands on this and like breaks something or electrocutes themselves, because that would be very bad and he doesn't want that. But yeah, essentially this is an open source design, and yeah, like I said, you just take the plans. Like, you have to be a member of HWBot and have to show some accomplishments that, you know, you can tell that, okay, you know what you're doing, you are able to put an EPower together. And then you take the plans and you go to PCBWay and order a PCB like this. And I would like to use this moment to give you a little bit more info about our sponsor PCBWay. Before we continue, I'd like to thank my sponsor PCBWay. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. So yeah, in terms of price and availability, this EPower is basically perfect, because as far as I can tell, the plans are free, and the availability is as long as you can order PCBs online. So that is pretty great. There is one caveat though, and that is that, you know, you get the PCB and that's it. You don't get the components that go on the PCB. You have to find those yourself. And this is where it gets a little bit into it. This is the part where you really have to know what you're doing, because you have to then solder all the components yourself. No, you don't have to go and buy all the individual components, because this, again, is a little bit like those EPowers you make from cutting old cards in half, because all these components can be sourced from one very specific card line. Specifically the GTX 500 line from Asus, the DirectCO2 line. As far as I know, the GTX 560, 560 Ti, 570 and 580 DirectCO2 all have the exact same components. They have the same MOSFETs, the same capacitors, the same inductors, the same controller and all the same supporting circuitry. The only difference being that the 580 uses this controller in an 8-phase configuration, or the other cards uses them in a 6-phase configuration. And I think some of the cards only come with one high-side MOSFET, whereas the 580 and maybe one of the 560 versions comes with 2 high-sides. This right here has 2 high-sides soldered per phase. If you get one of the cards that only has one, then you would be missing a high-side MOSFET for each phase here, which isn't a really big issue. It does make the EPower slightly more powerful, but like, it will work with just one high-side MOSFET, that's fine. And yeah, so you have to find one of these cards, like used or broken, which is fairly easy. At least in Germany, like one of those 560 DirectCO2 cards, 15 euros, sometimes 10 euros. You get that. Like, you can get broken ones pretty safely as well, because usually GTX 500 series cards, when they are broken, it's the core or the memory. The VRMs are pretty much always fine. I've only ever had one single VRM failure on a Fermi card that wasn't even a 500 series, it was a 400 series. A 480 where a memory VRM high-side MOSFET blew up, which is completely irrelevant to this, because this only takes the vCore VRM components. So yeah, that's fine. So you get one of these used cards, usually very cheap, and then you need to transplant all the components from that card onto this PCB. And after you've done that, you've got a working EPower, because this requires no extra components. This can be completely built with just the components you get off that card, which is really, really cool. especially considering how much functionality this EPower has just working with those base components, because you'd be guessing, well, it's just gonna be the same as, you know, using the stock PCB, but, you know, with a better attachment point, because you get this massive V-core and ground stripe on the front and back. So it's easier to attach, and it's somewhat easier to work with because everything is nicely spaced out. Like, you can see the size difference. It is quite huge. The next version is going to be a bit smaller, but it is going to retain the spacing between the components. Actually, as far as I know, they're going to be spaced out even more for the controller area to make, you know, making it easier. But yeah, you would think that this doesn't have that much functionality, but it does, and it's really cool what you can do just working with the base components. So let's go into a little bit into the systems present on the EPower board. So first of all, here we have a vid table. There's a tiny little error in this. The B2 version says that vid 7 is a offset switch. It is not. It is in fact a 800 millivolt just set. So that's going to be fixed in the B3 version. Like, again, everything. B2 is not the final one. It is an engineering sample, like you can see right here. So there's a newer version that's in the works right now. I have seen the plans. It does look like it's somewhat nearing completion, but I don't know the timeline. I just got these sent for testing and, you know, looking at it, making a video about it, because I think it is really cool. So yeah, so you have a vid table here, and the way how this works is it sets a default / starting voltage. Essentially how the vid works is the controller starts out with a voltage of, I think, 1.6125 volts, and then every pad you short reduces that voltage by its corresponding amount. So right now you see vid 6 and vid 1 are shorted, which means that we go from 1.6125 volts down to 1.2. So this, when starting up, will have an output voltage of 1.2 volts. And that is so that, well, because 1.6 is pretty high, so you don't want to blow up whatever you connect this to, because 1.6 is pretty high for the vid. So yeah, this is set to 1.2 volts default voltage right now. Then over here we have a whole bunch of probe points and also some more interesting ones. Specifically these two at the top here. Voltage sense and voltage sent ground reference. These are very important because without these connected, the EPower will not start. So right now as it is, it will not actually turn on, and this is by design. Because these two pins are the voltage sense. Because one big issue that you have with EPowers is that the EPower only regulates itself. It doesn't regulate the entire card as a whole like the stock VRM does. The stock VRM on a graphics card will have voltage read points closer to the thing you're trying to power, the GPU in this case. So it will know the exact voltage that's getting to the GPU, and it will compensate its output voltage based on that feedback. However, the EPower, because it is completely separate from the card, other than that it's feeding it power, cannot really tell what voltage gets here. It can only tell what voltage is leaving the EPower. And therefore the EPower cannot compensate for any voltage fluctuations that happen after the power leaves the EPower. So anything in the connections, anything in the power plane between the connecting point and the GPU, all of that cannot be compensated for. And that causes a pretty big issue because your idle to load transition is going to have a massive voltage swing. You're going to be in situations where, like, you set 1.4 volts in idle and you start a benchmark and suddenly you are at 1 volt. That is just not really good, and that is something that, you know, you kind of just have to deal with EPowers up until now. So this is not completely new. The EPower 5 already had that functionality, and you can add it somewhat easily to your DIY EPowers too. I even did this on a GTX 780. I made a whole video about that, so you can check that out if you want. But what this is meant to be used is that you don't connect this to the output on the EPower. You connect this to like a capacitor on the backside of the GPU. And then the EPower will use that voltage on the backside of the GPU, which is very, very close to what actual voltage the GPU is getting, to compensate the output. So it doesn't really care what happens right here, it cares about what happens at the thing you're trying to power with this. And that means this can compensate for that huge voltage drop, and also just additionally it can compensate for any resistances or inductances that are in your connections or in the power plane. So this will just literally give you better voltage regulation, and that is a very cool feature that is implemented perfectly here because you literally just solder a wire to this and you're good. And that is really, 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 really useful. Like, this is probably the best feature on this EPower. And it really forces you to use it. Like the EPower 5 from EVGA, it does work without doing that, and it will just use, you know, the regular output to compensate. And a lot of people don't even know that that feature exists on the EPower 5. So I like that this EPower forces you to use it, because you really should use it. It's a very good feature to just have much better voltage regulation. Then we have a bunch of read points, you know, ground, power, return, ground, ground again, 3.3 volts, 5 volts. And then down here we have an I2C interface, which is cool. I didn't know this controller supports I2C, but we have an SCL and an SDA pin. And again, a nice detail that I like is that on both sides you get ground pins. So the interesting thing about I2C is there's actually no standard pinout in like which pin arrangement. So sometimes you have SDA in the middle and sometimes you have SCL in the middle. And this giving you ground on both sides means you don't need to swap around connections in your connector. You just swap around the entire connector and you get something that lines up correctly, which is cool. I like that. That is really nice. That is just a small extra thought that makes using this more convenient. And the EPower is full of these things. There's really a lot of thought that went into this design. It is a really cool thing that Asyq made. Then on the right side we have more adjustment. Over here we can disable the overcurrent protection, so the top pad when shorted disables per phase and the second pad disables total overcurrent protection. Sometimes you need to disable the overcurrent protection you have because when you're really pushing something, you sometimes for short bursts go over the current threshold where it would just turn itself off from overcurrent protection. You can overstress VRM components for short amounts of time. They will be fine, they will just blow up if you do that long term. So for those cases you can disable the overcurrent protection either per phase or just completely by shorting the two top pads. And then the bottom two pads enable these two headers over here. So the top one enables switching frequency adjust and the bottom one enables feedback adjust. Feedback adjust is your regular voltage adjustment potentiometer like on this, like the blue potentiometer here. Adjusts the output voltage because using only the VID table to adjust the voltage is a bit annoying. I would just use the VID to set a standard starting voltage and then use a potentiometer to fine-tune everything. And that is what this is meant for. So you enable the functionality by shorting this pad. Then over here is another pad that you can either short like it is here, or you can put a limiting resistor here, which will limit the maximum voltage that you can get out of this feature. Because over here you can just directly solder on a potentiometer. And what can happen is if you set the potentiometer to just have zero resistance, to just be short, well, that will correspond to infinite output voltage, so in other words 12 volts, which would not only blow up all the capacitors here, but also the thing you're powering. So to prevent mishaps like that, you can put a limiting resistor here. It even suggests values on the silk screen, which is really cool. So if you are worried about that, you can put a limiting resistor here, and then even if your potentiometer is set to zero resistance, you will still have that limiting resistor, and you can limit the output voltage to a value that you like. Same thing with switching frequency. Adjusting this is not always necessary. That it's kind of rare that you need to touch this, but if you need to, you can. Same idea, you enable it by shorting the pad. You can put a limiting resistor here so you don't set the switching frequency so high that all your high sides go boom. And then you use a potentiometer to fine-tune the adjustment. And yeah, that is the features essentially. It is just really cool, like how convenient this entire thing is. It's just, like, this is more features than the Galax EPower had, like the big 16-phase EPower they have. What you get on there is a VID table. And that's how you have to set the voltage. You don't get fine adjustment like here. You just have to use the VID table, and then maybe there's a dip switch to disable the overcurrent protection. And that's really it for the big Galax EPower. So this little one-man project is literally better. It's not better in current capability. This is not 16 phase, this is 6 phase. So this is not going to power a 980 Ti on LN2, but considering what it is really damn impressive. And of course, this working means that there's now the possibility of making further projects in the future, which is something that I'm really excited about. So I've already talked about the B3 version. I've seen the plans for it, and Asyq does talk a little bit more in detail about this on his own channel, so definitely give his channel a look. He definitely deserves more subscribers than he currently has. And yeah, so the B3 version is going to make the entire EPower a little bit smaller, so it is more in line with something like this, by just putting the components closer together where you can, and actually pulling them further apart for here, which is supposed to make soldering and assembly easier. It will fix like tiny little mistakes like the VID7 description right here. There was also something about the hole spacing for the two 6-pins that, because there's two different variants of the 6-pin connector, one has a slightly different hole spacing, so this will change the hole spacing to be compatible with both kinds. And other tiny changes, something like having a ground and VCore strip on both sides. Right now you get VCore on the top and ground on the bottom, which, you know, can work, but again, there's no standard way to make a PCB. Sometimes it's flipped on the card you're trying to power, and then you would have to solder the EPower on upside down, which is bad because then this right here doesn't get any cooling. So the B3 version will have a ground and VCore strip on both sides of the PCB, so that, you know, whatever you can solder it on whatever orientation you want. And yeah, like, just if you want more detail, go watch Asyq's video about this. He explains it in a bit more detail. And then one thing that I'm a little bit speculating about, you know, one thing that would be really cool in the future is for a theoretical B4 version, or maybe even C1 version, I don't really know. Because this is still based off that GTX 560 or 570, 580, you know, the Asus Direct CO2 VRM from the 500 series. I was thinking, the main issue with this right now, that's probably going to prevent a lot of people who would be interested in this project from not doing this project, is the fact that you have to assemble this yourself. You know, you have to buy that Asus 500 series card, you have to transplant all the VRM components, which is, don't underestimate that. These are very small components, and especially getting the controller on correctly is pretty hard. And that is probably going to prevent quite a few people from doing this project who would otherwise want to do it. So I'm thinking, and I'm pretty sure I've suggested this to Asyq as well, for like a future version, once this is more or less the way he wants it, to make a new project that is inspired by this, that instead of using components off of an old 500 series card, uses components that are still actively available, that you can buy new, and then you can make use of something like PCBWay's PCB assembly services, where they not only make the base PCB for you, but you also send them a parts list, and then they get the components and solder them onto the PCB, and then what you get sent from them is just a completely finished functional EPower. Now that is going to be a little bit more expensive, but it is going to make the entire thing a lot easier to work with, because you don't have to do any soldering work outside of attaching the EPower yourself. And of course this also opens up possibilities with more modern VRM components, like these components are more than 10 years old. But yeah, like, this is going to drive up the price a bit, but it should still be significantly cheaper than something like an EPower 5. And I'm pretty sure that, you know, it would be fair. Like, you could, with more modern components, you know, like, I don't know, make a 10-phase VRM, maybe 12-phase. There are a lot of very high phase count controllers these days. Back then, like 6 or 8 was basically the highest you could go. But yeah, that's the thing that I'm hoping for in the future out of this project, that there's going to be a version of this that uses still currently available components that you can then order completed, and you don't have to do the soldering yourself. Because I think that would open this project up to a lot more people, and then the fact that this is, essentially an open source design means that we will never run out of these. Like, you just need the plans and you can order them yourself. You don't need to depend on like EVGA still making EPower 5s, because they stopped making them. They no longer make GPU stuff, and therefore EPower 5s are gone now. Like, the only way to get one is to find one used or find some old stock, which is basically all gone now, so good luck. And that's the thing I care about, that like the overclocking community gets an EPower that like belongs to the community and not some hardware manufacturer. And so like, I mean, Asyq holds all the rights to this. He can do with this project what he wants, but from what I've seen and heard, this would essentially be that. And I'm really hoping that this is going to be a thing. I don't know if it's going to be a thing like that. I just really would think it would be cool. Or at least if Asyq is done with this project and releases the files, that maybe someone else picks this up and does something like that. Because having like this community-owned open source EPower design would be amazing. This would be really, really cool. Like, just, yeah, this would be amazing. And yeah, with that, I think I'm done with talking about all of this, like, just really cool project. I love EPowers, and I love the fact that Asyq has gone and just made his own. As for, I am going to look into using this as well. He has used one of his on an HD 6750, I think. For the next cheap-ass chips, I'm going to look into maybe using this. Either I'm gonna use this or this for 81, but I kind of want to use this because just, the extra cool factor. And I'm of course looking forward to a B3 version when he finishes it, if I can get one. And then, yeah, I'm gonna try to keep suggesting to him to just like make that theoretical, modern version of it, where you can just order it completed, because that would just, yeah, that would be really cool. Anyway, I think I've repeated myself enough times now. So thank you all for watching. And until next time, goodbye.